Thank you so much. Thank you so much for inviting me for the talk today. My name is Robin de Vries. I work for the Ocean Cleanup. I work in the research team, and today I'll give you a presentation about the ocean cleanup from space. How is this plastic pollution visible from space, and what role can the very high resolution imagery such as Pleiades Neo play in the domain? So here you already see the plastic on the water, but this image is just taken with a camera. So no, how do you say, no success yet, but I'll show you something. So, but first of all, what are we doing with the ocean cleanup, right? Well, we try to save these animals here. This was the 2017 World Press photo in the category nature, where we see the sea turtle entangled in a ghost net. This is what we don't want. And so every day, plastics in the ocean cause a lot of harm to marine creatures, and they pollute the oceans also by degradation into microplastics. A lot of the plastic is coming from rivers too, in development countries such as in the Dominican Republic, where this photo is taken. We see that there's a general lack of infrastructure. So in this picture, you can also clearly see the city, and here's the river flowing into the ocean. But there are really vast quantities of plastic entering the ocean every day through these pathways. So it's definitely a problem that needs to be solved. And that's what we try to do. So the Ocean Cleanup, about us, we started in 2013. And our mission is developing and scaling technologies to rid the world's ocean of plastic. We work largely from the Netherlands in Rotterdam, but we work with a very international team, a very diverse team, and we have activities basically all around the world. We don't have cleanups everywhere, but we are really trying and working towards cleanups all around the world. And at the moment, we do this with 120 crew members. So you can already see some nice pictures, but I'll show you some more just to show a little bit more who we are. We recently launched our newest interceptor in the Klang River in Malaysia, which is actually connected to the band Coldplay, Interceptor 005. It's also nicknamed Neon Moon. We launched ocean cleanup sunglasses, and actually this year we sold them out, or they are almost sold out. So I think it's too late to get them, but we will think about the next product that we can make actually from ocean plastic. And this is really products that we fully make from ocean plastic. So no tricks or anything. It's really proven that it's 100% start to end ocean plastic. We also have some success with our system 2, Jenny. You can see her here, or at least the result here in the top left, where we extract really tons of plastic from the ocean. And you can see the ghost nets, but also hard plastics, all intertwined. So the crew on board is working hard every day to separate those plastics and to basically sort them through. So we try to expand our cleanup to as many places as we can. Always try to find the best solution for the place, as we have learned. So now, of course, this talk should be about satellites. So why are we interested in satellites? Well, as you can see, the ocean is a pretty big area, especially the open ocean. Flying planes or drones over it is very expensive, and actually you won't cover all of the area. So it has a large potential for us to basically map plastics in the open ocean. However, there are several challenges to it, so I'll come to them later. But in the end, finer resolution is definitely better, and it allows us to see plastic and distinguish them from waves, for example. So at the Ocean Cleanup, we work a lot with predictive models of where plastic is concentrated. Here you can see one on the map. This area here is called Great Pacific Garbage Patch, which is not an island of plastic, but it's a high concentration zone. So basically, you will see water, but you will also see plastic every now and then if you sail through it. but this is a model, and we know that those areas can change position or change in concentration over time. So we also need observations. So we are working from both ends, models and observations, to get a better view on where the cleanup is needed most effectively. And so that's what we try to do, also with satellite imagery in the end. So just taking a step back, we as the Ocean Cleanup do some work with satellite remote sensing of plastics, but in general, there's quite a big increase of research in the domain. So the European Space Agency is funding quite a few studies at the moment. They will be published by a lot soon, so stay tuned there. NASA in the USA is also working on a few studies. So generally, you see things are coming up, but a big side note for all these items is that they're based largely on anomaly detection, so detecting large quantities of offshore debris from satellite images. And so to detect really the ghost nets, something else will be needed, and this is still difficult to do. Another approach is to use radar actually to map those garbage patches, such as the GPGP here. And it's a super exciting and new approach, but also here for the ocean cleanup, we are interested in even more actual and granular data than the outputs that come from these methods. So I'm taking you through a slideshow of a few images that we took from space when we were there in the Great Pacific Garbage Patch. Okay, it's very hard to actually get an image like this. The system is always moving, and so what you see is you have to time exactly when the satellite is going to have an overpass, and you need to predict the route of the system very accurately. So in this case, if you look well, here is an image from the 21st of September 2021, where you can see our system sailing through from afar. And so what you can also see is there's a lot of waves and a lot of clouds. And these prove to be a terrible challenge in terms of detecting marine debris. So what we do is we wait for the optimal weather. If we actually zoom in here, you can see those waves a little bit more, that there is a lot of reflection that makes it difficult to actually map loose plastics floating around. And it might sound a bit crazy, but in the end, it is definitely what we were interested in. Here is another try that we did one day earlier, the 20th September 2021. It's also still a beautiful image, but again, we see large waves, very noisy in that sense. This is not the fault of the satellite image, not the fault of Airbus who made this, but it's really the fault of the ocean, which is so dynamic and always changing. So we kept trying, and in the end, we got this beautiful image in October 2021 with very, very optimal conditions. So you can see the sea is like a mirror, and the acquisition geometry is really perfectly timed. So there are no reflections for waves or whatsoever. So this is the type of images we like to work with, and you can see that this is not Pleiadic Neo. We will definitely try that soon as well, but it already shows the potential that if you time it well, you get nice images. And one of these images from a different time, actually, we already did a case study. We also published it on a blog with Airbus. And we can actually, when the weather conditions are so great, we can actually map points of interest on the ocean surface. All the red dots here are objects that we detected using our machine learning algorithm, which only works for nice weather, unfortunately. But we can then actually go and count the number of plastics in the image over a very large area. When we discard the areas of clouds, we can also estimate the numerical density of those bigger plastics. And it turns out to be quite a reasonable number, quite close to what we know about the GPGP. But such said, it's still quite experimental. So I'm just showing you one of the fortunate events where we were able to do this. I'm also going to take you through some of our deployment locations with the Interceptor, our river cleanup system, and also to show you a little bit the difference that it can make with Pleiades Neo. So this is the image from Pleiades. I notice there's a small spelling mistake here. The accent should be above the E instead of the I. But anyway, here you see our interceptor here in the zoom in. So if we do the same for Neo, we can really see an increase of resolution and contrast as well. And we can start to distinguish really more details. So in this case, there is a tiny blob here, which turns out to be, in fact, a little blue boat. And also, more disturbingly, here these areas are called water hyacinths. These are river plants, invasive species. And in there you see those speckles, and well, it's hard to prove, but it could very well be that this is actually also plastic being transported into the river and therefore also into the ocean. So, well, I'll show you two more locations. In this case, this is our interceptor in Jakarta, Indonesia. And again, this is then the old Pleiades, and this will be the new one, where you can definitely see the increase in detail. So it's only from 50 centimeters to 30. You might think, well, it's still 30, but it really makes an incredible difference when you try to distinguish things like small boats or small plastics, for that matter. And the final one, I like it. It's my personal favorite. I think it's because of this very beautiful temple here. This is in Malaysia, in the Klang River. And again, here we have the interceptor. We have a highway and everything. It's quite an interesting picture to look at. And when we go to Pleiades Neo, again, the resolution increases a lot. And as cherry on the cake, we also did get a drone image of this area. We have some really good drone pilots in our organization, and that looks like this. Well, I will go as far as to say it's not so different from Pleiades Neo anymore. So you get this very high detail images, even from space, and we don't have to fly the drone. I will still compliment the photographer of this photo from our team. It's a very beautiful shot, but I would like to make that bet. So in summary, to close out, I'm also taking my time, I see. High resolution imagery provides this information you can often not get in any way else. You might be able to fly an airplane or a drone, but you will not be able to do that over such a large area. So I showed you the remote sensing of plastic litter from space. There are some cool successes, but it's also still in pioneering phase. However, there are really a lot of scientific studies that will be coming out soon. They're materializing. So all the puzzle pieces are being made at the moment by different scientists all around the world. So I'd like to close out by saying that this higher spatial resolution can certainly make a difference for marine debris detection. And so we are also watching this technology with extremely high interest. Then I would like to thank you for listening, and I hope you enjoyed the presentation. Thanks a lot.